Welcome to myprojectbazaar.com. Now let's see about robust perceptual image hashing based on ring partition and NMF. Now let's see about the abstract. We propose a new framework to hash the image processing functions such as JPEG compression, watermarking, image rotation, gamma correction, brightness and contrast adjustment, and Gaussian low pass filtering. So rotation manipulation take image center as the original of the coordinates. Then after modified the image, it will pass to the ring partition. The ring partition can be done by calculating the circle radii and the distance between the each pixels and the image center. After ring partition, it will pass to the NMF. NMF stands for the non-negative matrix factorization. So it distinguishes from other methods by non-negative constraint. This allows a part-based representation based only additive combinations are allowed. Finally, from the hash values, we identify the original and the reference images. After hashing, we analyze about our classification. Then we find the performance of our result. A key component of our hashing is the construction of secondary image, which is used for the first time in image hashing. After that, the resistance to rotation discriminative capability of the proposed hashing is attributed to the use of NMF, which is good at learning parts-based representation. Now let's see about the flow. Here we have to given the input image. For identifying the modification, we are going to modify the image based on the image processing task, so that here we are implementing the modification in the pre-processing step. In pre-processing step, we are applying the JPEG compression, image rotation, gamma correction, low pass filtering, rotation scaling, and likewise the 8 modification are implemented. Based on these 2 modification, it will identify whether it is modified or not. So after pre-processing, it will pass to the ring partition. Here the images are segmented as the set of rings. Rotation and manipulation takes image center as the origin of the coordinates. So based on the radius, it will be segmented as rings. So here we segment the 7 rings. After ring segmentation, the segmented ring will pass to the NMF. Here NMF represents the non-negative factorization, so it will identify the non-negativity constraint. This allows a parts-based representation because only additive combinations are allowed. So after identifying the NMF features, it will go to the image hashing. It is to project the data into low-dimensional binary humming space. That is, each data is mapped to a bit vector called the hash key. So each hash function must be satisfy the locality sensitive property. So after hashing, it will be identified whether it is similar to our original image or not. So it will be checking based on the threshold value. So if it is the hash value is less than the threshold, it will be original image. Otherwise, it will be detected as a modified image. So it will go to the analysis step. In analysis, we are identifying the PSNR MSE values, and we are check the quality factor of the image. Now let's see the demo. Here I am having hashing main.m file. Select this file, right click and run the file. So this is our guide design. So initially we have to given the input image. In dataset, totally I am having the 6 sample image. Now I am selecting one image. This is the input image. The input image will be modified by the 8 tasks. So these are the 8 tasks such as original JPEG compression, rotation. This will be implemented to the original image. Now I am giving one gamma correction is implemented to the image. So for the gamma correction, both input and gamma correction will pass to the ring partition. This is the ring partition image of the input and the partition modified image. After that, we are identifying the NMF. So these are the NMF feature of the modified image, and then it will go to the image hashing. So it will identify the original image and the reference image, and as also it will predict that the two images are different because it will be affected by the gamma correction. It will be identified based on the hashing technique. For the hashing technique, we set the threshold value. If the hash value is less than the threshold, it will be original, otherwise it is a modified. In analysis, we are identifying the properties of the input image. So this is the hash length, and PSNR MSE values are identified for the modified image, and the hash value is the displayed here. Now I am showing the result of image hashing technique. Here we are steg analysis the image whether it is modified or not based on the image hashing technique. Thank you.